In electrical engineering, the maximum power theorem states that to obtain maximum external power from a finite internal resistance, the resistance of the source must be equal to the resistance of the load as viewed from its output terminals. Today, we are going to try and derive that condition, the maximum power theorem, or call it the maximum power transfer theorem. Right here we have a circuit diagram. We have an EMF from this source, and this EMF and this source has got an internal resistance R, which you can also call the source resistance. This circuit has got a resistor that is connected to it. So E is EMF, V is the terminal potential difference across those terminals, and the lost potential difference at the end of these terminals is going to be the potential difference that is lost. The lost potential difference is going to be equal to the EMF minus the terminal PD. In our previous videos, we said that EMF is the potential difference across the terminals of a cell when there is no current flowing out of this cell. And the terminal potential difference is the potential difference that is across the terminals of the cell when the cell is connected in a circuit. We all know that terminal potential difference will be less than the EMF. Why is it less? It is because some PD is lost due to the internal resistance at the source. So that PD that is lost is what we are going to get by multiplying the current that is being supplied by the source times the internal resistance of that cell. So IR is going to be equal to EMF E minus V. And here when we get the current, we make I the subject of the formula, we get that I is going to be equal to E over R plus R. This is the current that is flowing through that circuit. So from our formula for power dissipated in a circuit is going to be the square of current, multiply that by the resistance. And if we are to substitute for the value of I here, when we substitute it becomes like this. We end up with power being equal to E squared R, divide that by R plus R in brackets squared. So since we are trying to derive the maximum power theorem, it means that for power to be maximum, we simply have to differentiate this whole expression. And we know that the derivative of this expression, the PDR, is going to be equal to 0. We are going to differentiate with respect to the resistor in the circuit. So since this is a quotient, we are going to use the quotient rule to differentiate. Using the quotient rule means that the PDR is going to be equal to 0. This is our U, that is our V. So meaning that V, which is this, R plus R squared, multiply that by the derivative of U. The derivative of U, since we are differentiating with respect to R, it means it's going to be E squared, is going to be equal to U. Our U is E squared R, and that is going to be that E squared R. Multiply that by the V dx, or the derivative of V with respect to R, which is going to be this. It's going to be 2 times R plus R. Divide that by V squared. RV is R plus R in bracket squared, so V squared is going to be this to the power 4. So now here we have finished the differentiation, and this is equal to 0. So the rest is to reorganize it. So when we prime factorize, we factorize out the common terms. They are E squared R plus R into that over 4. We go ahead, one of these dies with that. You remain with R plus R to the power 3 in the denominator. So that's going to be equal to E squared into R plus R minus 2R is going to be equal to 0. You end up with this expression. So either from this expression, this is equal to 0. For this to be equal to 0, either this is supposed to be equal to 0 or that is supposed to be infinity. But if R plus R is equal to infinity, it means that either the value of the resistance in the circuit will be too large, and if it is too large, it means that no current will be able to flow through it. So we'll ignore it and consider this. So either R minus R is equal to 0, and that will make R be equal to R. So this confirms, or it proves that theorem, the maximum power transfer theorem, which states that to obtain maximum external power from a finite internal resistance, the resistance of the source must be equal to the resistance of the load as viewed from its output terminals. So R must be equal to R. And if we are to put this back into this expression, where there is R, we put capital R, we end up with that expression for maximum power as E squared R is equal to 4R. This brings us to the end of this video. Thanks for watching. Somebody out there would like to watch this tutorial. Please don't forget to like and share. For more videos, simply subscribe to this channel. Catch you in the next video. For Kisembo Academy, this is Arnold Rangakuramya.